Hi, I'm David Ellis with Ball Aerospace, and Director of Strategic Capabilities and Partnerships. In that role, my team looks at future state of the industry, capabilities we need to bring into our systems, and how to meet critical capabilities for our customer set. I also look at partnerships across government and the industry to find best technology to bring to our mission systems. Today I'm going to talk to you about two things. One is our Rideshare program, where we demonstrate technologies on orbit, and one specific technology, which is our open framework for data processing. So here's our Rideshare program charter. We see that technology refresh is going faster. A lot of our customers want more affordable solutions, and they want to minimize non-recurring engineering. To do that, we want to be able to demonstrate the ability to integrate things quickly, pull different capabilities from different vendors, different mission sets, to go fast, break things, and learn along the way. So the ethos of this system is really orbital demonstrations of those capabilities and supporting technology demonstrations for both our engineering units and our business areas. So our software framework that we're flying on our first Rideshare, and will fly on future Rideshares and missions, is really based around open standards. We have an electronics infrastructure that we might build internally at Ball, we might get from different vendors or partners, but on top of that, we generally will boot a Linux OS. From that point, we can fly a number of different apps. Some apps in Linux are monolithic. We might compile them and build them specifically to run right on Linux. We also have the Kubernetes platform, which allows us to do container orchestration. So we can fly a number of containerized applications, service those, update those on orbit, and orchestrate them in ways that we need to for the mission. Ball has a series of common services that we use, such as message passing, data access, telemetry services that we can also bring along with first or third-party applications. Generally speaking, for our avionics, we have a few key tenets. One is a modular design that allows us to mix and match different capabilities we need for mission space. And we try to be standards-based as much as possible. Things like Space VPX, the SOSA and MOSA standards, very important to Ball and to our customers, and we try to service those in our architecture. These things support a rapid integration strategy, so we can mix and match quickly, boot the software on board, upload the applications, and get moving on the mission. So let's talk about our first Rideshare effort, which is on orbit right now. We had a general mission in mind. We did some simulation and some testing on the ground in our lab facilities. And then we pulled the mission together, including a Linux-based software package that we talked about previously. And we got some COTS hardware from one of our commercial vendors that was a good stand-in for typical mission avionics. We were able to integrate first and third-party AI components, which was doing some data processing, get those on orbit. It's flying currently. We've met all of our mission capability demonstrations, and it was a complete success. So here's an example of the Rideshare control system. Depending on the Rideshare vendor we use, there are different APIs to control the system, to get our data, to upload commands, and we do that through this web-based interface, which is running in our cloud environment. So you can see here we can track the state of the mission, we can view current telemetry, and we can queue up commands to do different types of experiments as needed on the mission. So our next Rideshare is currently in build, and we are expanding our Rideshare program on this to include several different types of sensors and different types of hardware and software. Mission Priority 1 is a temperature profile sounder, so we're integrating some RF components from our RF group to do temperature profiles in the atmosphere. We're also flying a COTS SWIR camera for environmental sensing. We're able to take image data and post-process to extract meaningful information for our weather folks. We have some secondary missions, including our mission enabling software, which I talked about previously. And then we're flying some next generation onboard storage. Storage is becoming a big deal in space. Being able to store vast quantities of data and process that data on orbit is key. So we're following the SOSA standard here with one of our partners to fly that technology. We also have first and third party containers as we did on the first Rideshare. These are all integrated together into the Rideshare platform, and we can see how that is integrated into the space station environment. So we're flying with Airbus on the next platform, which is the Bartolomeo system, rides on the ISS. We integrate into that system and follow the Airbus APIs to move data back and forth from the space station. On the ground, again, we have our cloud-based control environment, this time interacting with Airbus APIs to send and receive data from the mission as we move along. So in conclusion, Ball sees the space market as continually evolving. We see a renewed desire for faster technology, for software-defined missions, for more affordable solutions, and an ability to minimize non-recurring engineering across different mission spaces. Our Rideshare program is responding to this by using agile methodologies to integrate and fly capabilities quickly, to show mission context and mission need, and we're working with our partners across the industry to make that happen. Thank you.